Welcome to The Explainer. Today, we're going to pull back the curtain on the magic behind the stunning visuals in your favorite video games, how they go from simple code to breathtaking reality, one tiny frame at a time. I mean, just look at this scene. It feels so real, doesn't it? The way the light hits the metal, all the textures, the incredibly complex shapes. But here's the thing. This isn't a photograph. It's an entire world, a single moment in time, built from absolutely nothing but pure data inside a computer. But here's where it gets really wild. This one image, this single frame you're looking at, is actually made of 3.5 million tiny flat triangles, all stitched together like a quilt. And those 3.5 million triangles, well, they're defined by over 2.1 million individual points just floating in a virtual 3D space. We call these points vertices, and they are, quite literally, the building blocks of everything you see on screen. But the most mind-bending part of all this amazing artistic detail, all this geometry and color, it all comes from the simplest source imaginable. Billions and billions of ones and zeros, all processed at unbelievable speeds by your graphics card. So that's the big question for today, isn't it? How on earth does a machine turn abstract binary code into a world you feel like you can step into? How does it decide what to show you and how to draw it all? Well, the answer is this incredible process called the 3D graphics pipeline. You can think of it like a hyper-fast factory assembly line. It takes in all that raw data and, in a series of steps, transforms it into a fully rendered image, all in a fraction of a second. So let's follow the data on its journey. We're going to go through 3 main stages. First, figuring out where everything goes. Next, painting in all the pixels. And finally, adding that realistic light and shadow that makes it all pop. All right, let's jump right into step 1, Vertex Shading. The whole point of this stage is actually pretty straightforward. The computer just needs to figure out what your in-game camera can see and where all those things should show up on your flat TV or monitor. So your GPU, your graphics processing unit, does a whole bunch of really clever math. It takes all those millions of 3D points in the game world and projects them onto the 2D surface of your screen. It's kind of like taking a real 3D sculpture and trying to figure out exactly where its shadow would fall on a flat wall. And you know, the system is really smart about this. It doesn't waste its energy. In that train scene, for example, there might be over 1,000 different models in the entire level, but the GPU only bothers processing the 600 or so that you can actually see. That kind of optimization is absolutely critical. And to crunch all those numbers for millions and millions of points, a modern GPU is, well, it's an absolute beast. We're talking about something that can perform up to 35 trillion with a T calculations every single second. It's just mind-boggling. So all that firepower gets us our basic outline. We've got the wireframe of the scene, but now we've got to color it in, right? It's just a bunch of empty triangles. And that's where rasterization comes in. Basically, the GPU goes through every single one of those 2D triangles and figures out, okay, which pixels on the screen actually fall inside this shape. Each of those pixels is now called a fragment. It's like a candidate just waiting for some color. But wait a second. This brings up a huge problem. What happens when you have a bunch of triangles overlapping in the same spot? How does the computer possibly know that the train is supposed to be in front of the station and not behind it? The solution is actually super clever. It's called the Z-buffer. Think of it like a depth map for your screen. For every single pixel, it keeps track of how far away the object covering it is from the camera. So if a new triangle shows up, but it's behind what's already there, the GPU just throws it away. Simple as that. Only the closest thing makes the cut. Okay, so now we have solid shapes, but they're still, well, they're flat. They look like cartoons. The final step, fragment shading, is where the real artistry happens. This is where we add light and shadow to make it all look real.